Hi Addie, welcome to today's lesson. This is lesson number 41 and it's on page 165 in your algebra book. So today we are going to talk about addition of like terms, okay? And remember what a like term is. It means the variable is the same. So it's like when you have something like 2x plus 3x is equal to 5x. Because the x's are the same variable, that means that those are like terms. And so you just add those coefficients together and it's easy peasy. It's not that bad. Of course, you're doing more complicated problems than that because they have ratios or fractions in them. And also they're going to have some exponents on those variables, and some of those exponents are going to be negative. So it's definitely adding like terms at the level that you are at, which is super awesome and fun. And the next thing we're going to learn how to do is a two-step problem. Okay, so that doesn't seem that bad. Only 2 steps, right? It'll be great. So this is the second time I started recording this video because I zoomed in to show you this little cartoon and realized that I don't think this lady was wearing a very modest swimsuit in the original picture. But I still like the little, I don't know, I thought it was kind of funny, so I still kind of liked it. So I just put a swimsuit on her. I drew that. All right, so if you watch Jaws backwards, it becomes a heartwarming tale about a fish that fixes boats and gives limbs to disabled people. I thought that was kind of funny. Anyway, I thought that was pretty funny. So let's move on. Let's do addition of like terms in rational expressions. Okay, here's what we're going to do. Now, this is the expression that they give us. I mean, have you seen a more complicated problem than that? And you might be like this guy being like, where is the like terms? Because sometimes once these problems get really complicated, it's really difficult to see if there are even like terms. So this is an example of that. When we look at this rational expression, rational means there's some fractions or ratios in it. We have to look really hard for the like terms. It turns out, and I'll just spoiler alert, this term and this term is a like term, but we have to do a little bit of simplifying before we can figure out that it's a like term. So the easiest way to do that is to rewrite the problem so that all the exponents are positive. None of these negative exponents, that's just crazy talk. So step one, and this isn't even the two-step problems, we haven't even got to that yet, but let's just rewrite this whole expression so that all of the exponents are positive. And then let's see what we have. And we'll simplify this one a little bit because you can see there's an x on top and an x on the bottom. Actually, I'll just do that right now. Check it out. Because when there's an x on top and an x on the bottom, that turns that into a 2. Because you can cancel one of the x's. Does that make sense? Let me do that again. And I'll show you why. If I erase this x, this is actually x times x times x. And then you can easily see that one of those x's cancels out. And so you're only left with x squared on the bottom because there's 2 x's there, right? So instead of writing it like that, you could easily write it like that. You probably already knew that, but I'm just making that point just to make sure that you know it. So I'm going to take this whole thing and rewrite it so that the exponents are all positive. All you have to do, easy peasy, move that y to the top and change the sign of the exponent. Okay, so that becomes by squared over x squared. Okay, and then let's look at the middle term now. I want to change this so that all of the exponents are positive. This one's negative, so I'm looking at that x to the minus 2. All I want to do is make it a fraction, move the x on the bottom, and change the sign of that exponent. So when I do that, this becomes this. See, that x is now on the bottom, and it's x squared, positive exponent. Okay, let's look at this last one. This cannot be simplified anymore. I know that because there's only y's on top and there's only x's on the bottom. And all of the exponents are positive, so I don't need to do anything with that. I just need to add that to my simplified expression. Okay, so now I've got a more simplified expression here. This is the same as the problem that they gave us. It's just simplified and it's changed so that all the exponents are positive. So now that I do that, I can see that this term is the same as this term, because only look at the variables. Forget the 3. Look at the variables. You've got a b, you've got a b, you've got a y squared, you've got a y squared, you've got an x squared, you've got an x squared. They're exactly the same, other than the 3, right? But the 3 doesn't matter. I mean, you could have a 1 right here, right? You could have a 1. You can put a 1 anywhere. It doesn't change anything. So I see that those are both like terms. So now I know I can combine them. This is the same as saying 1x minus 3x, right? What would you get if you were doing 1x minus 3x? You would get negative 2x. It's the same with this. If you have like terms, it doesn't matter if it's an x or if it's a by squared over x squared. If it's 1 by squared over x squared minus 3 by squared over x squared, you get negative 2 by squared over x squared, right? Does that make sense? So you can combine these into one, and it becomes that. Now, this is not a like term. This third one is not a like term. Why? Because it's not the same. If you look at the variables, there's a b on top here. There's no b on top over there. There's a b on the bottom. You can't combine that. I mean, you could move the b up, but then it would be b to the minus 1, and that's not the same. It has to be, the variables have to be exactly the same. So that one you cannot combine, so you just have to bring it down and just add it to the end of this whole expression. And so that's the simplified version, and this is the answer. Okay, so there you go, right? The last term, because it's different, you cannot add it together. All right, now, this is the right answer with all the exponents being positive. If you are a crazy person, like it appears this lady is, or if you are one of the mean torturer writers of math questions, you might say, you know what? Take this whole thing and write it so that all the exponents are negative. Yeah, a crazy test writer would do that, and then someone taking the test would maybe look like that. All right, so that's actually not that hard. All you do is you're going to move everything around. So I'm going to like take this x squared and move it up and then change, whoops. Oh my goodness, I made it upside down. And then change the sign. How about if I just erase it and change it to a minus 2? And then I'm going to take the b to the, whoops, oh my goodness. I can't, seriously, it's late at night. And then I'm going to do b minus 1. Same thing with the y squared. We're going to move that down and change it to y negative 2. And then I just kind of, you know, do that. So you can see how I moved everything around. I just moved things from the top to the bottom, bottom to the top. They just want to get you used to doing that. So this is going to move down. And then this y squared is going to be negative 2. And then all this, I'll just do it in one step. I'll move it up. But if you do it in one step like that, you got to remember to add that exponent to every, change the sign on every exponent. And that b does have an exponent, right? When it was down here, it was b to the 1. We move it up, it's b to the negative 1. So this is how the problem would look if you just change all the exponents to negative. And, oh, we can't forget about that final term, right? The final term is this one that we got to add on to the end. And otherwise, we did that. We got that, right? All right. There we go. That's all there is to it. That's the final answer, right? Oh, yeah, I know what this is. This one's not the final answer that we're looking at right here. What this is can you do the whole problem? Instead of changing all the exponents to positive, can you change all the exponents to negative and then simplify like terms? Yeah, you could. Again, you'd have to be kind of a crazy person because this is hard to keep track of, I feel like. It's a little harder. But you can do it because you've got this and you notice that actually that's the same as that. So that is a like term. And this is like 1 minus 3. And again, you get negative 2. And then you've got the variable, which is exactly the same. And then you add on this at the end because where else are you going to put it? You can't add it together to anything. So that just has to be added on the end. Oh, you noticed, Harry. I know that you noticed it before I even said anything about it, right? All right. Hi, Harry Styles. He wants us to do some examples here, so we're going to do it. Let's do example 41.1. Okay, in this example, the instructions are simplify by adding like terms. So first, we have to get out those binoculars. Which ones are the like terms? It's not necessarily going to be the first two ones again, but it could be, so we have to look carefully and see which ones are like terms. And if it's hard to see, what we're going to do is, well, even if it's easy to see, we rewrite it so that all the exponents are positive. Okay, so that's going to be step 1. Rewrite everything so that all the exponents are positive. So let's start with this first term right here. Oops, erase. Okay, let's start with this first one. What's negative? We've got that's a negative. All right, so I'm going to bring this up and I'm going to change it to a positive 2. Okay, easy. So far, so good. Oops. So far, so good. We're doing great, right? We're doing great. Yes, hang in there. All right, what about this second term? What is negative? The negative is this, right? So let's bring this down. There's no, officially no, line, but that's no problem. We can make one. And then don't forget to change the sign. Okay, and then I'm just going to make that look a little prettier so it lines up because I'm a little OCD. All right, so now, oh, you know what? We got to go back to the first term. We forgot to do something. We forgot to simplify because check it out. There's an x on the top, there's an x on the bottom. This x cancels out one of those x's. So if I erase this x, it erases one of those x's, but there's still 2 x's left. Okay. Anything else we can simplify while I'm here? I don't think so. Okay, what about this second term? Anything I can simplify? Nope, I don't think so. All right, let's look at this third term then. Anything that's negative? Yeah, that b to the negative 1, that's negative. Let's put it on the top and change the sign of the exponent. In fact, we can erase the 1 because it's given that there's a 1, right? You don't have to write it. It's just assumed. All right. Check it out. You've got a by squared over x squared. You've got a by squared over x squared. You've got a y squared b over x squared. Does that matter? No, it doesn't matter. It's still by squared, right? Because it doesn't matter if you do 3 times 1 or 1 times 3. That's a property of multiplication, right? You can just, I'm just going to erase that. It doesn't matter. Well, the order, if you are multiplying 2 things, 2 times 3 is the same as 3 times 2. So that's all they did. They changed the order, but that doesn't matter. It's still a like term. So these are all like terms because the variables are the same. So now all I need to do is add up their coefficients there, right? There's no coefficient here, but there's a 1. So we can just write a 1 there. So now we do 1 minus 3, what are we at? Negative 2 plus 4, so we're at positive 2. So the answer is positive 2 by squared over x squared. When you add up variables, the variables don't change. You just add the coefficients, but the variables stay the same. Okay, so this is the final answer. Bam, that wasn't too hard. I love it. Actually, that was not only not hard, but it was really satisfying. Oh, yes, this is super satisfying to do. Let's do the next example, 41.2. We're going to simplify by adding like terms. So the first step is to rewrite so that all the exponents are positive. So let's look at this term. What is negative? This is negative. So let's move that a to the -3 down and then change the sign. The b is also negative. Let's move that up and don't forget to change the sign. And then I make it look a little prettier. I'll just do this 3. Okay. Now let's do the next one. Oh, no, we got to simplify. We got to simplify. Look, we got a b cubed times another b. Well, that can be simplified. That's a b to the 4th. Okay. Does that make sense? Because b cubed times another b, this first b is just actually b times b times b because it's b cubed. So now how many b's do we have altogether? We have 4. So that's easy. We can simplify that. All right, now let's look at this next term. All the exponents are already positive, and there's nothing on the top and the bottom that I can simplify. So that's it. This one's already done. It came done. That's cool. So let's look at if we have any like terms between these two. So if we only look at the variables, we have b4 over a3. b4 over a3. Yes! So the variables are the same. So we can assume there's a 1 here. And all we have to do is add 1 plus 2. And the answer is going to be 3b4 over a3. That was so fun. Let's make sure we got it right. Yep, the book got the same answer as me, so we're going to assume that we got it right. That was so much fun that I want to do another one. Let's do another one. Should we, hairstyles? Yes, we should. Okay. This example. This one looks a little more complicated. There's lots of numbers and letters, and there's 3 terms, but we're going to start in the same way. We're going to write each term with positive exponents. I mean, you could be a crazy person and do it with all negative exponents, but it's just a little trickier. So let's look at this first term. This is a negative exponent, so let's take that a to the -3 down, change the sign. Sweet. What about the c? Actually, let's move the b over. The c is negative, so I'm going to bring that up and change the sign. Then I'm going to make everything look a little prettier. Okay, sweet. Now, what about this second term? Let's look at this. Is there anything negative? Yes, this c to the -1, that can be changed. We will bring that up and just make it a c to the +1. Actually, you don't even need the 1. Let's go back to the first term and erase that 1 because you don't need a 1. It's just given, right? All right, so there we go. That's the second term. And I can see already that this is going to be a like term with this. It looks the same, right? Okay, let's do this third term. We've got b squared on top. We've got a cubed on the bottom, and then you've got a c on the bottom. Nothing is negative. There's no negative exponent, so I can't change the top to bottom, anything like that. Also, I can't simplify, so there's not an extra c on top that I could cancel out or nothing like that, right? So we have to leave this the way it is. Now, the next step, oh, I'm so tired. That's okay. The next step is to identify like terms. Which variables are the same? We already decided this and this are the same, but this one is not. One of these things is not like the other. Okay, so we take the 2 things that are the same and we add up their coefficients. 7 minus 5, and I'm using minus because of that negative sign there, that subtract sign. So because it's kind of like plus a -5. Remember that? Okay, so 7 minus 5 is 2. And then once I have the 2, it's easy. I just write all the variables exactly the same. So we took care of that term, we took care of that term, but we did not take care of this yet. So that's easy though. All you have to do is just take that whole thing. Oops, how about I just take that, whoops, son of a nutcracker. Okay, I just take that whole thing and bring it down. put a plus sign in between, and then this is my final answer. Okay, that's cool. That's the end of the problem. Sweet. Now, one more little concept for us to go over. Two-step problems, right? You're probably feeling like this. You take one step forward, 2 steps back. Oh, I've had those days. So some steps require 2 steps for their solution. Some problems require this. So the answer for the first step, you use that for the second step. I know that doesn't make sense yet until we actually do it. So let's just start with an example. And the problem is this. This is what they say. If x plus 3 is equal to 7, what is the value of x minus 8? Now, if they just asked us what's x minus 8, we wouldn't know. We wouldn't know the answer. But they give us this information. So we can solve and figure out what x is by solving the first equation. Easy. X plus 3 is equal to 7. That's so easy. You just subtract 3 from both sides, and these cancel out. So you have x is equal to 7 minus 3, which is 4. Okay, now you take this answer and figure out the second part of the problem. Because they're saying if x plus 3 is 7, then what is the value of x minus 8? So now we use 4 to figure out the value of x minus 8. So instead of x minus 8, we put in a substitution. And it's going to be 4 minus 8, because that's what we figured x was. 4 minus 8 is negative 4. So that's the answer. The answer is negative 4. Easy. So easy. Sometimes my brain is 2 steps ahead of my feet. Yeah. Okay, so let's do the next one. This one is saying, if x minus 5 equals 7, what is the value of x plus 4? So we're going to solve this in 2 steps. This is step 1, and then we're going to use whatever we get for x for this step 2. So let's start with x minus 5 equals 7. We're going to add 5 to both sides, and then these 5 cancel out, and so you have x is equal to 12. Then we take this value of 12, plug it in here. What's 12 plus 4? 12 plus 4 is 16, and that's the final answer. That is it, Addie. Guess what? That is it. Oh, I can't believe I didn't end with a GIF. I thought I did. Oh, yeah, there is one. He's so happy that the lesson is over. Yeah, and now you get to go do your homework. Love you, Addie. Have a great day. Bye.